Ah, and now maybe you can even hear me. So let's see, is that a little bit better for the folks who are watching online? Sorry, I've been standing here waving my hands and yeah. What I was saying is hopefully you've seen the news item that says that you can attend in person. There is a form that I'd ask people to fill out so we can keep a handle on the numbers. We need to keep it under 100. I don't think that's very likely to be a problem in a class with 118 people registered. I think even if this were an in-person semester, I would have a hard time getting 100 people at this point in the semester for a class with 118. But still, we need to keep an eye on the numbers, so please check out that news item and fill out that form. If you're here today and you didn't fill out the form, you don't have to leave. Because we're definitely under 100 today, but for the future, it would be good if you could indeed fill that out. Okay, so someone says, yep, there it is, audio is back, fantastic. So yes, it does seem that there's something wrong with Top Hat Chat today. And so people, well, at least I haven't been able to sign into it. I don't know, can people in the room sign into Top Hat Chat? No. It makes like a Hall of Mirrors effect where you click on chat and then it opens the thing, you click on chat and it, yeah, okay. All right, so everybody's having that issue, not just me. That's nice to know. Okay, so today we are going to start talking about some new data structures, some new things that we haven't learned about yet. And we're going to start with tuples. Someone says, nope, not working for me either. Okay, yeah, that's the Top Hat Chat thing. It's not working for you either. Okay, so we're going to start talking about tuples. Now, what have we been talking about recently? Objects, methods, and we talked about some of the common methods that we find in list and string. And I should say, by the way, so for today, the YouTube chat is enabled, so people can use YouTube chat. Don't feel like you have to participate in YouTube chat because it's going to require you to sign in with your personal Google account, and if you don't want to do that, that's 100% fine. Nobody has to. It's just sort of a fallback thing while Top Hat Chat is not working. But if you want to, you can certainly feel free to. So, what are some common methods that we find in things like list and string? Or should I say in lists and in strings? Anybody want to type or say some things that we commonly find in lists and strings? Well, we could do a little exploration with Thani. So let me make a list. 1, 2, 3, heffalump. Oh, sorry, 1, 2, heffalump. And how about a string, which is ng1020? So if I type dir on L, we're going to see some things like, well, we can clear a list, we can copy a list, we can extend a list with another list, we can use the index method. So if I try to use, what is the index of heffalump, then it's going to give me the value 2. So that's all very good. Somebody's saying join, append, find. Yep, so these are some methods of string. So we've got lots of methods of string, right? Is this an ASCII string? Is it something that can be represented with those original ASCII characters? And we're going to see later, well, actually, no, we've seen ordinal values that just range from 0 to 127. Is it a space? Is it title case, uppercase, lowercase? Lots of useful things like that. Good. So we've talked about some of those things. Now, I've previously, I think, used the word tuple, and you've definitely heard the word tuple at some point in your life when you were talking about mathematics. When we say something is quintuple something else, well, that tuple or tuple is kind of getting at the same thing. If I use the word tuple in a previous lecture, I said we'll come to that stuff later. Guess what? Later is now. Tomorrow has become today, as it inevitably does, and we have new stuff. So we've at least heard tuple at the end of a word before, right? So we can talk about quadrupling something, but if you want to multiply something by 5, we would quintuple that thing. There's also sextuple and septuple and octuple, I think, and nontuple, maybe? But more generically, you'll sometimes see, if you read papers that involve mathematics in them, people will talk about an n-tuple, which means a thing that has n things in it. Well, that kind of sounds familiar. Do we have a way to, in Python, construct a thing that has n things in it? What do we use? Or what have we seen that we can use, I should say? Pardon? Okay, so if we want to iterate over a bunch of things, we could do that with a for loop, that's right. How would we create a thing that has a bunch of things in it? There we go. Lists are what we've seen thus far. So if we have this type that we can already use to create a thing that has a bunch of things in it, why would we want a tuple? Well, a tuple is a little bit different from a list. It is actually more limited, more restricted. We can do fewer things with it, but that turns out to be useful when we are working with them, and we can do some kind of fun things with them. All right, so what is a tuple? A tuple is an ordered collection, so it's a collection of values inside of a single value. And how is this different from a list? Well, it's an immutable ordered collection. So does anybody know what the word mutable means in life as well as in programming? What does it mean to say something is mutable? Mutable can also mean... All right, we've got a limited group who are typing in the chat, and there's a small enough group here that everyone feels self-conscious about just shouting things out. That's okay. Mutable means changeable. So if you have a document that is supposed to be preserved in its current form for all time, we would refer to that as an immutable document, something that cannot change, or at least shouldn't change. We use the same words in programming. Things that are mutable are things that we can modify, things that we can change, and things that are immutable are things that we can't change. So what category would a list fall into? So if I've got my list L, which contains the values 1, 2, and heffalump, can I change values inside of my list? Yes, that's right, I sure can. So I could say element 1 is now 42. And now I can look at my list and we can say, all right, my list now contains 142 and heffalump. I doubt my children are watching this, but if they are, they're probably giggling quite dramatically at the use of heffalump in a university lecture. That's fine. Okay, so it's an immutable ordered collection, and in Python we represent the tuple type using parentheses where we would use square brackets for a list. So in the way that we can create, in the way that we can create a list here, we can also create a tuple which contains 1, 2, and heffalump. But now when I try to modify element 1 within the tuple, well, look at this. We get an error because it says you're not allowed to change the value inside of a tuple. Someone says, what's a heffalump? Oh, fair question. A heffalump is a fictitious creature from Winnie the Pooh. So Winnie the Pooh was afraid of heffalumps and woozles because they steal honey. And yes, heffalumps don't actually exist, though. You'll be relieved to know. The things that actually steal honey are children with sticky little fingers. Sorry, it's my son's birthday today, so you can everybody say happy birthday to him.
Happy birthday.
There we go. That'll be fun. I'll play that back for him later. Yes?
Could you explain the difference between tuples and lists again?
Yep. So the difference is that, well, there are a few differences. The only difference we've talked about so far is that a tuple is immutable, so you cannot change its values. Whereas a list, I could create a list, and I could put a bunch of values in. I could pass that list into your function, and then into a function that you wrote, and then inside of your function you could change all the values inside of my list. Now, Maybe that's okay. Maybe I want you to do that. But in some circumstances, it can be quite helpful to know that a value is not going to change if you pass it into some code that doesn't do exactly what you would expect. So that is one of the key differences between a list and a tuple. Now the syntax is also slightly different here. As you can see, we're using parentheses to create it rather than square brackets. But it is, but so far the only difference, or the other difference we've talked about that's really important, is that a tuple is immutable. Someone says a tuple is the opposite of a list. I wouldn't say it's the opposite of a list. I would say they are both ordered collections. So if it was going to be the opposite, then it would be like a disordered anti-collection or something. So no, I wouldn't say it's an opposite, but they are quite different in some important ways. So they're both ways of storing a bunch of values, and we're going to talk about a bunch of ways of storing different values. We'll talk about sets on Wednesday, which are not necessarily ordered, but they are ways of storing a bunch of values, but you only store one of each value. We'll talk about dictionaries on Friday, which is another way of storing values where keys map to values. So there's lots of different collections that can store different types of values inside of a single value. Lists and tuples are very, very similar in that they're both ordered collections. It's a bunch of things in a specific order. Lists are mutable, tuples are not mutable. Oh, and we've got a bunch of happy birthdays in the chat too, so thank you. All right, so where do we use tuples? So we can use tuples when we're storing sequences of things, very simple sequences of things. But one place that we use tuples a lot in Python is when we are returning multiple things from a function. So this question came up earlier where somebody asked, I think it was pretty early on, and so sitting in my office and a question came up in the Top Hat chat. Don't remember who asked it, but somebody said, can I return more than one thing from a list? And I was like, well, yes and no. In the sense of, for now, we're going to say that you can only return one thing. Later, we'll talk about a technique by which you can return multiple things, but you're still sort of only returning one thing. How in the world did that work? Well, that worked by returning a tuple. So let's write a function that divides a numerator by a denominator. Okay, so def divide numerator by denominator. So def define function, name of the function, valid identifier, and those things inside of the parentheses, are they arguments or parameters? Parameters, yes, good. All right, so we can start, as we always do, by describing the function. So this will divide two integers. But what's going to be special about this function is it's going to do integer math, but it's not just going to return the quotient, whichever the result of integer division is called, quotient, dividend, something like that. It's going to return that thing, and it's also going to return the remainder, returning both the, maybe somebody can either in the chat or something very quickly tell me, what is this called? I'm going to, for now, call it the quotient. So how in the world are we going to get both the quotient? Well, first of all, let's get the quotient and the remainder. So what is the, I'm for the moment calling it a quotient. What is the, or how do we divide two integers and get the integer division result? Two slashes, that's right. And how do we get the remainder? Well, that was a bit odd. Maybe this is a little bit of fallout from the whatchamacallit, freezing rain, sorry. As soon as I said the word fallout, I started to think of more serious things, which hopefully is not that. There we go. So we get the remainder by using the percent sign, the modulus operator. So now if we want to return both of these, we can actually return a tuple of quotient and remainder. Nobody's told me in the chat yet whether it's called the quotient or the dividend. So yeah, this is not a math lecture. If we had a, yeah. If there's any math professors who are watching this right now, I'm deeply sorry, but that's okay. So that is how we can return both the quotient and the remainder. Now, if I want to save this, what's this, lecture 21, right? Yeah. There we go. So if I want to run this program, we've now defined a function called divide. So if I want to divide 11 by 3, what's this going to print out for me? Just guesses. Somebody said quotient is right. I mean, I make no apologies to math professors. I know what I'm talking about. What's this going to print out? What are we going to see? Well, we are going to see a tuple. And so that tuple is 3, 2, because 11 divided by 3 is 3 remainder 2. Someone says I was just about to say quotient. Good, good. We're getting participatory and interactive again. So this is good. And actually, we'll come back to how we would use that if we were to call the divide function in just a few minutes. All right, and so there might be some other functions that we bump into that use tuples. In fact, a lot of like standard library Python functions and methods and things that you will use as you just sort of explore Python a bit more. So we're giving you tools, putting tools in your programming toolbox, but then eventually the idea is that you're going to kind of go out into the world and explore and learn more things on your own. And we're going to give you a foundation that will allow you to go off and learn more stuff and then use more libraries and more packages and more APIs that we haven't explicitly taught you, but we're going to give you the foundation. Well, you're going to see a lot of things out there that return tuples. And in just a minute, we'll give you a couple of examples. Before we do, show you a couple more things. If you want to have a tuple that has just one element in it, right? So we can have a list that has one element in it, right? A very short list is equal to 3. There we go, right? So that is a list. It's not a very long list, but that's okay because its name is a very short list. So it has just the number 3 in it. If I try to write a very short tuple with an ironically long name, there we go. What's that going to evaluate to? What's that going to evaluate to? Open parenthesis, 3, close parenthesis. If we hadn't said anything about tuples, if I hadn't taught you anything about tuples, and you just looked at open parenthesis, 3, close parenthesis, what would you say that evaluates to? Someone says invalid. Well, is it invalid? Let's, if I write 1, or 1 inside of parentheses, or in fact, I mean, in math, I could write 1 plus 2 plus 3. Or if I wanted to, I could just write 1 plus 3 in parentheses. Right? Parentheses in a mathematical expression just mean do this part first. So if I write this, well, we're just saying here's an expression. That expression is a really simple one. It just has a single literal value, 3. Now, the fact that I put that 3 inside of parentheses, I mean, it's still just a number 3, right? And so, in fact, if I try to create this very short tuple with an ironically long name, we're going to see that, in fact, we don't get a tuple. We just have the number 3. So if we ever want to represent a tuple that has one value in it, what did other tuples that we've written recently look like? How did they look different from this? So a tuple that has 2 elements in it, how do we write that? Someone's got it in the chat. Well, almost actually. So you'll notice that here's a tuple that we wrote. And look, it's got parentheses, but it's got elements that are separated by a comma. And so if we want to have a tuple that has just one element in it, we can put a comma in it, just like that. So just like if I want to have a list, I can have a list 1, 2, 3, and actually I can have a comma after the last element if I want to. Similarly, I can do this. I can have a tuple that has a comma after the last element, or I can have a tuple that has a comma after the last element. It's just there's only one element in it. So in this case, that comma is significant because that comma is telling Python, dear Python, this is not parentheses as we would use for that mathematical operator to express precedence. Do this part of the expression first. Instead, that comma is saying, hey Python, this is a tuple. This is not just an expression. And so the comma says now we have a tuple. If I were to type, what is the type of a very short, let's see if I can do this in front of a live audience. Oh, that's good. That's good. I don't normally manage to type quickly in front of people correctly. But yeah, so if I were to run the type function here and pass our value, a very short tuple with an ironically long name, into type, what's it going to print? Any thoughts? It's going to type, it's going to print tuple. Just like, well, what is the type of a list? It's list. What is the type of the number 3? It's int. What is the type of the value true? Well, it's bool. Well, tuple is also a type. And so we can use, we got it in the chat there, good. And so we can use, just like with the other types that we've seen, list, int, bool, etc., there is also a function called tuple that we can use to convert things into tuples. So I could convert a list into a tuple, or I could convert a tuple into a list. And these are both things we can convert back and forth. So if you have a tuple and you want it to be mutable because you want to change things and you want to update things and you want to do some math and modify values that are inside of that thing. So maybe you've got a list which represents a bunch of raw sensor readings, and then you want to change it to, instead of being analog sensor readings in the lab, you want to change it to represent temperature values, or you have calibrated your light sensor, so you don't want values between 0 and 750. You want actual values of lux between 0 and 250 lux, or whatever the top end of that range is. If you want to be able to change things, you might convert a tuple into a list. Someone says, we cannot append to a tuple. Yes, that is absolutely right. Tuples are immutable, so we can't add new elements to them. So if we want to create a single element tuple, we can put a comma in it. Now let me just take a quick peek here. Let's see if we are now, no, almost. All right, one more slide, and then I'll ask you a question. So we can create tuples by putting a bunch of values together with parentheses and commas and things. But we can also do something in Python that's called destructuring tuples, which is taking tuples apart. And this is a really useful thing when we want to, well, take a tuple and assign things to values. And so the way we destructure things is, so far in assignment statements, we've only ever seen on the left-hand side what? What's been on the left-hand side of an assignment statement?
Variable.
Right, so a variable name. Well, now we're going to see that if we happen to know that the thing on the right is a tuple that has 2 elements in it, then we can write 2 variables. And so earlier we wrote this function called divide. And I said if we divide 11 by 3, we get 3 remainder 2. Well, if we wanted to use that function, we might, for example, say that a quotient, comma, remainder is assigned by the result of calling the divide function. So this is saying I know that the divide function is going to return both a quotient and a remainder as a tuple, and now I can pull those 2 things. I can take that tuple and destructure it, break it into parts, and so now I have local variables q and r. that have the values 3 and 2 respectively. And this is helpful because then we might want to do something like print the result is Q remainder R. And it says the result is 3 remainder 2. Right, so this is also a really helpful thing. If you know that a function is going to return more than one thing, then you can kind of tell Python, I believe this function is going to return 2 things. So if it returns 3 things, then that's either the code is wrong or my understanding is wrong. One way or another, something is wrong. So would you please give an error? So if I, for example, try to, let's see, ABC is assigned by divide 10, 4. There we go. We will get an error, and it says, nope, there aren't enough values to unpack. So if you ever see this error, and I think by corresponding with people about assignments and things, I think some people actually have seen this error in different contexts. If you ever see an error that says not enough values to unpack, well, what that means is you've said, I want to get 3 values out of this function that returns 3 values, and the function doesn't actually return 3 values. It's only returning 2 or 1 or something. Okay. Questions? There have been some coming in the chat, which is good. Other questions? If not, I'll ask you a question. And then suddenly people will want to ask questions. No? All right, well, that's fine. Let me ask you this. Actually, sorry, let me just join these 2 things together. There we go. So what does this print when we run it? Sorry, I'd finally figured out a nice setup for how to do things in my office, and now I have to figure out ever so slightly different ways to do things. Ba-bum-bum-ba-bum-ba-bum. All right, we've got some answers coming in. That's good. All right, I'll give you just a little bit more time on this one. All right, let's close this one out and maybe call it 5, 4, 3. Oh, now the answers start to jump up. 2, 1, and we'll close it. All right, and let's take a look at the responses that we have. Okay, so most people thought we were going to see 8, 5 in one way or another, with spaces, without spaces, with parentheses, without parentheses. Okay, good. So let us take a look and see what we actually see. So x comma y equals 1 comma 2 def foo x equals y equals x, return x plus 3 y plus 4, print foo of 5. Okay, whew, lots of detail there. So let's step through this one step at a time. So first of all, x comma y is equal to 1 comma 2. So we are assigning to two things at the same time. So that's kind of a neat little new trick that we have. By the way, it would behave exactly the same way if I wrote this. Oops. So we'd be creating a tuple that has two elements, and then we'd be destructuring it, breaking it up into x and y. Now, we are going to define a function called foo. Now, we don't have a local variable inside this function yet called y, so when we try to find that value of a default argument for y, it's going to be this global variable y, which contains, we look in the box and we see 2. Then we find a default argument for the y parameter, and it is whatever happens to be in this global variable x, which is 1. All right, so now we've defined our function where the default argument, and if you're doing this by hand in a test situation, you probably want to write down that default argument is now, it's not y, whatever y happens to be passed in or some other y, it is now the value 2. And that this default argument to our parameter y is 1. So now we're going to call this function. So we're going to call foo and pass in the argument 5. Where does the 5 go? Oops, I can't see the chat anymore. There we go. So where does the 5 go? All right. It goes to the x. Someone says can't see the variables. Yeah, it looks like there's something funny happening in the stream. How about if I do this? Will this be a bit better, hopefully? Or now do you see a bunch of black on the left-hand side? All right. So 5 is going to go into x, and y is going to get whatever its default argument was. So we are going to start calling foo, and x is going to be 5, and y is going to be 1, because that's what its default argument was. So now we're going to return a tuple, which contains x plus 3 and y plus 4. So x is 5, and again, this is something where if we weren't being nice and explicit in writing down which x and what its current value is, and this x have different values, it would be really easy to get confused at this point between x, is that this x or is it this x, or what if I had called the function with another variable that was called x or something? Boy, it'd be really confusing. But because we have written right here, and because we've been tracking along and writing, we have a box that's labeled x and it has the value 5 in it. We know that x plus 3 is 5 plus 3, which is 8. Y plus 4 is 1 plus 4, which is 5. And we return a tuple containing 8 comma 5. And then that is what gets printed. Now, I'm not going to penalize you, Marks, if you didn't have it formatted exactly that way, like if you didn't have the space there or something, or if you didn't have the parentheses, that's okay. It's clear that you still got the question right. By the way, for the people who are watching online, did it help when I resized Thani, or did that create black bars at the side? Because there does seem to be something kind of funny happening with my stream as I'm looking at it in YouTube Studio. Not getting an answer, so we'll move on. And I'll just hope that you can see the slides. Hopefully, if you haven't been able to see the slides all this time, it would have been mentioned. Hopefully. All right, so another place where you're going to see code that returns multiple things is when we try to plot things using matplotlib. So there are functions that call or that return multiple things, and so you see here, if we look for help on this function called subplots, and subplots is really useful because it sets up a grid in which you can plot multiple things. So like you might want to have temperature over time and humidity over time and light over time and something else over time. You might want to have a bunch of things all plotted together, or you might want to have plots of here's the daily temperature in Newfoundland and in Labrador and in Cape Breton and in Halifax and whatever. You might want to have a bunch of plots that are somehow related to each other, and subplots are a good way to do that. But you see, it says it returns two things. And this is partly why we didn't go into too much detail about this API. It returns a figure object, which represents the whole figure, and then it also returns either an axes object, which represents an XY axis, or it contains a whole bunch of axes objects. So this is returning two things already, a figure and some axes. And then those axes may in fact be a NumPy array of, matplot, well anyway, it'll be an array of axes. And so here, if you'd seen this before, you'd say, wait a minute, how can a function return two things? And the answer is using a tuple. How would you access those two things? Well, I'm glad that you asked. Okay, it created black bars on the side. All right, so that means that, so that means that there's something wrong with the YouTube preview that I'm seeing here, but not with what you're seeing, which is what we want. So for example, and here's some code which 2 years ago during this lecture, this was stuff that we had been unfortunately starting to grapple with. So we wrote some, we had just started to have to do remote lectures and things like that. And so some example code that I provided to people, and you can still see it today. I stopped updating the actual data that was driving these plots after a while because, well, I didn't really want to continue tracking daily COVID numbers for 2 years because that turns out to be a lot of work. And there are other people who do that work very admirably. But at first, the CBC wasn't even plotting this kind of information for Newfoundland. So we did it in Engineering 1020. But you can see here that we use the subplots or the subplots function in order to create a figure that contains two plots that are related to each other, and they're actually over the same time scale, so it helps to be able to see cumulative things versus new things every day. And you see here that we are using Tuple Destructuring in order to grab both the figure and the axes so that I can do things to the figure, like create a big title for the whole figure, and then also set smaller titles on each of the smaller axes within this overall plot. And then we can do things like plot different values. So how do we use tuples? Well, we can use them a lot like lists in many senses. We can iterate over them, which means we can use that for loop to iterate over all of the elements in a tuple. We can use count. Tuples have a count method, which is quite helpful. They have an index method that we can use to look up specific values inside of a tuple. So let's try that. And I'll increase that size again. Oh, bother. Bonnie's trying to be clever. There we go. So if we have a tuple containing 1, 100, and 1,000, and what will this return? T.index100 will give me the number 1. That's right. How about T.index10? It's going to give us an error. So that is something that's a little bit different from like the string find method, which could return -1. So this is part of why when I gave you something that looked a bit like a find or index kind of method on the midterm, I said you can make whatever assumptions you like. Assume it creates an error, assume it returns -1, assume it returns none. Any of those would be fine. So tuple would have, like list, a count method. It'll have an index method. You can iterate over all of its elements like a list, but that's it. It doesn't have lots and lots of other methods in it, partly because you can't change the values inside of a tuple. So a tuple is a much simpler thing than a list. It is a simpler, more elegant data structure for a more civilized age. Is that the right quote? Something like that. And so it's simpler than a list, which means in some ways it's harder to make mistakes with it, which it turns out in programming is a really useful thing because we make mistakes all the time. If we do want to do slightly fancier things with tuples, one thing that we can do, and this is not something I will require you to know for the final exam, but you know, it's kind of fun and interesting. you can actually define a function in which you say, instead of saying, well, in addition to whatever positional and in addition to whatever parameters you explicitly define, some of which may have default arguments, some of which may not, at the end of that you can also define and then give me a tuple with all the other arguments. So something like the print function, this is how it works. The print function, you can pass in any number of arguments, right? You can pass in 1, 0, you can pass in 1,000,000 arguments to the print function. How does that work? Does it have an arg0 equals none, arg2 equals none, arg3 equals none? Well, no, it works like this. You can have a tuple of however many arguments you like after the other arguments. And you can also use tuples like this. So you can create a tuple and then say pass whatever values are inside this tuple as the arguments to this function. So here we have a function that has 2 parameters, so it takes 2 arguments, and so we have a tuple that has 2 values in it. So we can pass those 2 values as 2 arguments to the 2 parameters by using this asterisk in front of that tuple. So that's kind of a fun thing that we can do with arguments that allows us to write functions that are much, much more flexible. So now they can accept any number of arguments instead of just the specific number based on the parameters that you passed in. So that can be a helpful thing. But again, I'm not going to require anybody to use that, but if you're looking to have a little bit of extra fun with Python, then that's one place that you can look. All right, so a tuple is an ordered collection, like a list, but it's simpler than a list. There's lots of stuff you can't do with a tuple. It has way fewer methods, so it's kind of nice. It's a bit simpler, but also you can't change its values. It's immutable. But there is a bunch of useful stuff we can do with tuples, like we can use them to return more than one value from a function, and we can destructure them. So we can take a tuple and put it into a bunch of different variables, or however many variables we're supposed to have, and that can kind of be a useful thing. And then there's lots of useful things that we can do with tuples. So you'll see tuples again, whether it's in matplotlib code related to labs and stuff or other places. You'll see tuples all over the place. They're extremely useful and they're extremely common in Python, so you should know about them. All right. Any questions? So I do hope to have the next assignment up tonight. We'll see. After all of after my other class and then a lab and then some, birthday stuff that's going on. But I do hope to tonight get that other assignment out. It's in my head and I know what it's going to be, but I have to actually write it down in a way that is clear enough for everybody to understand. Yeah. All right. Someone says, what will it be? It will be something that asks you to write some modules that contain some functions related to probably, don't freak out, there's not 100% of the game, but they will be related to the game of chess. So I'll ask you to write some modules that contain some functions and stuff. All right. Well, then I guess that's it for now. So thanks very much for tuning in, and we will see each other again on Wednesday. Don't forget to check the course website with the news item about coming in person.